Okay, welcome to my video. It's me Kishore Lami. Today we are going to discuss about class 10 science first chapter, that is force, and basically here I have collected top 20 questions for each group A and group B test for the SE. So without any delay, let us start from question number 1. So question number 1, define universal gravitational constant. Universal gravitational constant, often called capital G, is defined as the force which exists between two bodies of unit masses kept at a unit distance from their center. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And question number 2, state Newton's universal law of gravitation. So Sir Isaac Newton had given that law, and as per that law, every body in the universe attracts every other bodies with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This means F is directly proportional to m1 into m2 and F is inversely proportional to d square. While combining this, we get F is equal to g m1 m2 by d square. Question number 3. State the factors that affect gravitational force. Here at first I would like to notify you all that we should write the formula for finding the causative factors. So the formula of gravitational force is F is equal to G m1 m2 by d square, where G is constant. Then the remaining m1 m2 and d are the factors. That's why factors that affect gravitational force are masses of the bodies and central distance between those bodies. And question number 4, what is gravity? Write down its unit in SI system. The force by which a body is attracted towards the center of the earth or a planet is called gravity. Its SI unit is Newton. Here we should not be confused that Newton is the SI unit of gravity, force as well as weight. And question number 5, what is acceleration due to gravity? In which unit is it measured? So we should not be confused that the acceleration only and acceleration due to gravity are same, but it's wrong. Acceleration is defined as the rate of change in velocity of moving body, but acceleration due to gravity is the acceleration produced on a freely falling body due to the effect of gravity. It is measured in meter per second square. And question number 6, write down the conclusion of Feather and Quine experiment. The famous scientist named Galileo Galilei had conducted that experiment, and as per that experiment, we can draw the conclusion that the acceleration produced on a freely falling body remains the same for all bodies, and it is independent of the mass of those bodies. What is weight? Question number 7. What is weight? Write down its unit in SI system. Weight is the gravity acting on a body. Its unit in SI system is Newton. As I have already told you that weight, gravity and force have the same unit. Question number 8. Define weightlessness and free fall. Weightlessness, the state of losing the weight. That means the state of a body having zero weight is called weightlessness. And when a body is falling freely only under the effect of gravity without any external resistance, means air resistance, then the state of body is called free fall. And question number 9. In which condition does an object fall freely? As from the definition, we can know that when there is no external resistance or air resistance, then the object falls freely. And question number 10. In which condition does a body of certain mass becomes weightless? When a body is in the state of free fall, or when the value of g is 0, then the body of certain mass becomes weightless. That is W is equal to mg. In case if g is equal to 0, and then m into g will be obviously 0 and the weight will be 0, hence the state of body will be weightless. And question number 11. Here this is very important question. This is 1 marks, very important short answer. And write the value of g on following places. Surface of the earth 9.8 meter per second square. We all know that because it is very important while solving out the numerical problems. And center of the earth 0. This in this state the body will have the state of weightlessness. And poles of the earth 9.83 meter per second square. Equatorial region 9.78 meter per second square. Moon surface 1.67 meter per second square. Jupiter surface 25.13 meter per second square. Here I have also included Moon and Jupiter in addition to the Earth, because both of them can also be very very important for the numerical problems, or about them they can be asked in some exams. Question number 12. When a feather and a coin are dropped towards the surface of Earth, do they reach the ground together? No. The coin reaches the ground first, because all we know it, because sometimes we have experienced that. So what is the reason behind this? Let me know. This is because the effect of your resistance is more on the feather in comparison to the coin. Yet this is group equation, that's why the reason must be short and sweet. And question number 13. State the factors affecting mass of a body. Factors affecting mass are size of atoms or molecules and number of atoms or molecules. How is the size and atom? And question number 14. State the factors that affect weight of a body. Weight of body, W is equal to mg. That's why factors affecting weight of a body are mass of the body and value of acceleration due to gravity, that is often called the small g. And question number 15. Write the relationship between acceleration due to gravity of a place and its radius. Here we know the formula that small g is equal to gm by r square. From that formula we can draw out the relation as g is directly proportional to 1 by r square. So in words, acceleration due to gravity of a place is inversely proportional to the square of its radius. Question number 16. What does it mean by the value of universal gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square? It means that a body of 1 kg mass attracts other body of same mass, that is 1 kg mass, with 6.67 into 10 to the power minus 11 Newton force from a unit distance. Suppose two bodies each of 1 kg mass are placed at a 1 meter distance. Then both of them will attract each other with a force which is equivalent to 6.67 into 10 to the power minus 11 Newton force. Question number 17. In which condition will the acceleration due to gravity of a falling parachute become zero? When upthrust of air is equal to force of gravity of the earth on a falling parachute, then its acceleration due to gravity will be zero. Here I would like to notify you that the direction of upthrust of air is always upwards, and the direction of force of gravity of the earth on something is downwards. When the falling parachute experiences the force from both upwards and downwards, then it cannot change its state, and its acceleration due to gravity will be zero. Question number 18. In which direction does the force of gravity act? As I have already told you that the force of gravity always acts towards the center of the earth or other heavenly bodies. Or sometime in which direction does the upthrust of air act? This question may be asked, and in this case we can say that it acts upwards. And question number 19. Write one effect seen on the ocean or sea due to the effect of gravitation between the sun and the moon. So, formation of tides on the seas and oceans is the effect of gravitation between the sun and the moon. Here, one question gets raised, that why isn't why aren't the tides formed on the water of lakes? This is because the mass of water in the lakes is very 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 larger than that of the seas and oceans. Due to this, only the water of oceans will be affected by the gravitational force between the sun and the moon, and as a result tides are formed. Question number 20. How many times will be the gravity of the earth if it is squeezed to the size of the moon? This question means that if the radius of the earth is made like that of the moon, then what happens to its gravity? So let me tell you answer. If the earth is squeezed to the size of the moon, then the gravity of the earth will increase by nearly 14 times. Not exact, but approximately 14 times. So all these questions were for group A, best for SE. I think all one of the questions is always asked in every term exams, scientific exams, and essay exams, I think. So be ready for that. And now let me come towards question number group B questions best for essay. Here many of questions are give reason, because these are very important, because they need creativity also. So question number 1, why is Newton's law of gravitation called the universal law? Previously we learned that Newton's universal law of gravitation. So why this law is called universal law? Let me tell you the reason. Newton's law of gravitation is called the universal law because this law is applicable to all the objects present in the universe, whether they are terrestrial or celestial. No matters the objects are on the earth or on the moon or in the space, this law is applicable for everywhere and for every objects. That's why it is called universal law. Question number 2. Sorry, here one I have written one, but the question number is 2. It becomes difficult to lift a larger stone than a smaller stone. Why? Here, this question we all know that we feel very difficult to lift a larger stone. But what is the reason that we cannot lift a larger stone is like the smaller one? So let me remind you. The effect of Earth gravity is more on a body of larger mass than that on a body of smaller mass. That's why it becomes difficult to lift a larger stone than a smaller one. As I've already told you that the effect of Earth gravity, it has a direction towards the center of the Earth or planet. That's why a stone of larger mass is attracted towards the Earth surface or center of the Earth. Due to this, we cannot lift it so easily. And now question number 3. Mention any two major consequences of gravitational force. Previously, we have learned the positive factors of gravitational force, but here, what are its consequences? What are its effects? So, following points highlight the major consequences of gravitational force. Point number 1, existence of solar system, galaxy, and constellations, and formation of tides on seas and oceans. Here I have mentioned only two, but many are the consequences of gravitational force, like rainfall on the earth, blowing of air, flowing of water, and revolving of the sun, revolving of planets around the sun, and revolving of satellites around the planets. So question number 4, why does the value of g differ from place to place on the earth's surface? As in group A, I have mentioned that the value of G, different value of G on the earth surface, like in polar region, in center of the earth surface, and equatorial region. So what is the reason behind the difference in the value of G? The value of G is inversely proportional to the square of radius of the earth. As we know, the earth is not As we know, the earth is not perfectly spherical. The radius is different from place to place. Thus, the value of g also differs from place to place. And we have a relation that g is inversely proportional to r square. The more the value of r, the larger the g will be, and the more larger the value of r, the more the g will be. That's why as the radius of the earth is different from place to place, the value of g is also different. Now question number 5. Differentiate between acceleration due to gravity and gravity. Here both of them looks like same, but they are actually different. So and first point, acceleration due to gravity is the acceleration produced on a freely falling body due to the effect of gravity. And gravity is the force by which a body is attracted towards the center of the earth or a planet. And SI unit of acceleration due to gravity is meter per second square, and SI unit of gravity is Newton. Here I would like to tell you that while finding out the differences between two particular objects, we should first mention their definitions, and in the second points, and in second the relative sentence. That means either unit or its characteristics we should mention there. Now question number 6. Differentiate between acceleration due to gravity and gravitational constant. This means sometimes the question will be like that. Differentiate between small g and capital G. Here small g means acceleration due to gravity and capital G means gravitational constant. So acceleration due to gravity. It is the acceleration produced on a freely falling body due to the effect of gravity and universal gravitational constant. It is the force which exists between two bodies of unit masses kept at a unit distance from their center. Acceleration due to gravity. Its SI unit is meter per second square, while the SI unit of universal gravitational constant is Newton meter square per kg square. Sorry, I have mentioned its value, but its value is right, but SI unit is Newton meter square per kg square. Now question number 7. Weight of a body is found less at the top of a mountain than at the bottom of it. Why? The value of G is more at the bottom of mountain due to less radius, and its value is less at the top of mountain due to more radius. Therefore, the weight of an object is less at the top of mountain than at the bottom. As we know that G is inversely proportional to R square. The more the value of R, the lesser the G, and the lesser the value of R, the more will be the G. That's why the weight of an object is more at the bottom of the mountain. So simply we can we can write that the value of G is the value of G is less at the top of mountain due to more radius. As we know, W is directly proportional to G. The weight of an object is less at the top of mountain than at the bottom. So this will be very easy. And question number 8. The weight of an object is more at the polar region than that in the equatorial region. Justify this statement. Here previously I have told you that uh, W is directly proportional to G and G is inversely proportional to R square. So any place which have more value of R, it will have high value of G, and the weight of an object will be more at that place, like that. The value of G is more at the poles, that is 9.83 meter per second square due to less radius, and the value of G is less at the equator, that is 9.78 meter per second square due to more radius. Therefore, the weight of an object is more at the polar region than that in the equatorial region. Here and the most simplest method to justify that which place is asked with more weight, mention that this place has more value of G due to less radius, and after that it will be very easy. And question number 9. The fall of parachute towards the earth's surface is not a free fall. Justify this statement. There is the presence of atmosphere around the surface of the earth which creates the external resistance. That's why the fall of parachute towards the earth's surface is not a free fall. Here we all know the definition of free fall, as it states the fall of body only under the effect of gravity without any external resistance. But in the case of earth, there is atmosphere which offers air resistance. That's why the state of the body will not be free fall. Question number 10. An astronaut feels weightlessness inside the spaceship. Why? When the astronaut is inside the spaceship, both the astronaut and the spaceship are in a continuous state of free fall towards the Earth's surface with the same acceleration due to gravity. So the astronaut doesn't exert any pressure inside the spaceship. As a result, the astronaut feels weightlessness due to zero reaction force. I think this is very long or difficult to. So if you can all of you need to mention in the answer, but if it is too difficult, then you can write just like this. When the astronaut is inside the spaceship, both the astronaut and the spaceship are in the continuous state of free fall towards the Earth's surface. As a result, the astronaut feels weightlessness due to zero reaction force. This will be very short and easy to. And question number 11. Parachutists are not hurt when they jump out of a plane from a very high place. Why? We all know that. We often see the parachute falling towards our surface, and at that moment the parachutists are not hurt. Why? Let me tell you the reason. A parachute opens and expands when a parachutist jumps out of a plane. The larger the area of parachute, the more the resistance of air. So the acceleration of the parachute decreases. Due to decreased acceleration caused by gravity, a parachutist falls slowly. As a result, a parachutist can balance his body and is not hurt when he jumps out of a plane. Okay. Simply, we can know that when a parachute opens and expands, its surface area increases, due to which it will experience more air resistance. As a result, it will fall down towards the earth surface very slowly, and the parachutist can balance his body. And hence, the parachutist isn't hurt when he jumps out of a plane. Now, question number 12. A satellite doesn't need any energy to revolve around the earth. Why? Till today, many scientists and many countries have sent their artificial satellites to have research about the earth. In that case, the satellites don't need any energy to revolve around the earth. What is the reason? So, let me tell you. A satellite doesn't need any energy to revolve around the earth because of the balanced centripetal and centrifugal force provided by the gravitational force. Here, the satellite is both attracted towards the center of the earth or deprived away from the center of the earth as a result of gravitational force. And when it experiences offers from both when it experiences force from both sides, it remains stable and revolve around the earth without any energy. So question number 13. The weight of a body is slightly more in Tarai region than in Himalayan region. Give reason. The radius of the earth is less in Tarai region than in Himalayan region. We all know. Due to this, the value of G is also more in Tarai region. Hence, the weight of the body is slightly more in Tarai region than the Himalayan region, as it is inversely proportional to square of the radius. This means the more the value of G, the more will be the weight. And the lesser the value of R, the more will be the G. That's why weight of the body is slightly more in Tarai region than in Himalayan region. Now question number 14. Kathmandu lies at a high altitude than Biratnagar from sea level. Where does an object has more weight? Give reason. Oh, this is very creative question. The weight of the body is more in Biratnagar. Simply we know that in Kathmandu, because weight of a body depends upon acceleration due to gravity. We know that W is equal to mg. As Biratnagar is at low altitude, it will have comparatively more value of g, and we know that the more the value of g, the more will be the weight of an object. So here this is the best way to mention your answer. Right, because weight of body depends upon acceleration due to gravity. As Biratnagar is at low altitude, its radius is less. Due to this, it will have comparatively more value of g, and we know that the more the value of g, the more will be the weight of an object. Hence, the object has more weight in Biratnagar. Question number 15. Acceleration due to gravity of the Earth is 9.8 meter per second square. What does it mean? So we all, in every numerical problems of this chapter, we need this value, that is 9.8 meter per second square, but we don't know what is the reason behind saying this. Now please be careful. Acceleration due to gravity of the earth is 9.8 meter per second square. It means that the velocity of a freely falling body towards the earth's surface increases by 9.8 meter per second in 1 second. Or it means that the earth produces an acceleration of 9.8 meter per second square on a freely falling body towards the earth's surface. Here I have mentioned two reasons, but the first one is the very suitable. Now question number 16. A large stone of 10 kg and a smaller stone of 5 kg are dropped simultaneously from certain height. Which will reach the earth's surface first? This question is also practical. We can also observe it in daily life. Now, what is the reason? Both the larger and smaller stones will reach the earth's surface at the same time. What a fantasy! Both of them, no matter they are which one is more weighty, but both of them reaches the earth's surface at the same time. This is because the acceleration produced on a freely falling body remains same for all bodies, and it is independent of the masses of those bodies. So their masses is negligible, or their masses doesn't affect how long does they take to reach towards the earth's surface. Now question number 17. At what condition a coin and a feather fall together? Also mention their acceleration at that time. In the absence of air resistance, a coin and a feather fall together. At that time, both of them have same acceleration. So, when there is no atmosphere or when there is no air, a coin and a feather fall together. That means they will have the state of free fall. Like that can be in the moon or in the vacuum. And at that time both of them have the same acceleration as both of them fall together simultaneously. Like that, question number 18. What happens when a coin and a feather are dropped on a lunar surface from the same height? Here lunar surface means the moon surface. Don't be confused. When a coin and a feather are dropped on the lunar surface from same height, both of them reach the surface simultaneously. This is because there is no air resistance due to absence of atmosphere, and we also know that acceleration due to gravity is same for all bodies. Here, no matter which surface area is more, either feather or a cone, but only the air resistance affect here. As there is no atmosphere, there will no air resistance. That's why both of them will have the state of free fall, both of them will have the same acceleration due to gravity, and both of them will reach the surface at the same time. Now question number 19. How much is the weight of a body less on the moon than on the earth? Also mention the region. Here at first I would like to ask a question that how much is the mass of body less on the moon than on the earth? Can you guess? I hope all of you can guess. Here we should not be confused that the mass of the body is constant in every corner, in every part of the world or the universe. Mass of body is same. Means a body of mass 50 kg will be same on the earth and on the moon. So in this case, the moon is smaller than the earth. Due to this, its gravity is 1 by 6 times of the earth. As a result, the weight of body is 1 by 6 times lesser on the moon than on the earth. Here we know that the value of small g is 9.8 on the earth and 1.67 on the moon. While dividing 9.8 by 1.67, we get approximately we get approximately 6 times. That's why a body weighs 1 by 6 times on the moon. Now question number 20. Under what condition the gravitational force, that is F, and gravitational constant, that is G, become equal? When the masses of two bodies are 1 kg each and the distance between their centers is 1 meter, then the gravitational force and gravitational constant become equal. Here I have also mentioned the formula, that is F is equal to G m1 m2 by d square, where G into m1 is 1 kg and m2 is 1 kg divided by d square, means 1 meter square. That will be equal to G because 1 cancel and we get F is equal to G. So at that condition the value of F will be equal to. Now all these questions are for group B. All these are very important for SE. But in the final, I would like to mention here the question of the day. Here the most important, most creative question, that is, what is weight of the body on the earth if the weight of body on the moon is 6 Newton? In the previous give reason we have also mentioned that, and here the weight of the body on the earth is 36 Newton if the weight of that body on the moon is 6 Newton, because the value of G is 6 times more on the earth than on the moon. Okay. Thank you for your help today. Now for this session, this is all. This is too sufficient, and in the next session I will be very prepared. I will very I am well prepared, and for now this is too sufficient. Thanks for watching this class site. Okay, bye.